Okay, folks, so today we're finding the molar mass again, except of compounds. So we're going to start with the molar mass of just regular elements at first, just like we did before. So if I go over here and I see aluminum, the molar mass is 26,982. So 26.982. Go back here. And so if I want to know the molar mass, it's 26.982. And what does that mean? That's how many grams of this stuff it would weigh per mole of that stuff. And that's it. Pretty easy. So that's the answer. Oxygen, O, let's go here. And then we're going to go find O. Here it is. 15.999. Pretty simple and straightforward. A little too easy, really. The answer is 15.999 grams per mole. Pretty simple. Now we're getting into compounds. See, we weren't in compounds before, so this is technically now this is a molecule or a compound. So a compound is two or more elements, and a molecule is technically two or more atoms. So this has got two atoms. This is two atoms, so this would be definitely a molecule. A molecule. Okay, this right here is a molecule because it's got two or more atoms in it too. So this is also a molecule. Okay, this is a molecule, but technically this is a compound because there's also two. So it's a molecule, yes. Why? Because it has two or more atoms. So it is a molecule. Is it a compound? Yes, it is a compound because it has two different elements. So how many atoms does this have? It has one oxygen and it has two hydrogen. So it has three atoms altogether. So definitely it's a molecule, but it's also a compound because it has two different ones. This one is a molecule because how many atoms does it have? It has two oxygen. So it's definitely a molecule, but it wouldn't be considered a compound because it's just one element. So if we want to figure this out, we know that one oxygen is 15.999, right? And there's two of them. So the answer is about 32 because it's like 16, right? I mean, if you want to know exactly, we can pull out the old calculator again. And we'll do 15.999 and we'll say times 2. It's almost 32, right? 31.998. And that's the answer. 31.998. That's how many grams per mole you will find of O2. By the way, when you breathe oxygen, you're pretty much breathing this. Oxygen doesn't exist in the air, like really. Like if you're breathing it around, you're not breathing this, just little oxygen atoms. They like to combine with stuff, and they'll combine with each other and make O2. So if you're breathing pure oxygen, you're technically breathing this, you know. But anyway, now let's get to a true compound, right? This one's got two different elements. Let's figure it out. So we have one oxygen, so we know that that one's 15.999, right? Grams per mole. So this is times 1. There's only one of them, right? Because there's no number here, right? So that means it's just one oxygen. But there's two of these hydrogens. That's why there's a 2 here, right? So you put a 2, H2O. And by the way, this is water. I think you guys already know that. H2O. That's the abbreviation or the compound for water. So H2O. So we got the one O right here. But there's two H's. How much does an H weigh, right? An H is right here. Technically, it's over here. That's just a sample. 1.008. But there's two of them. So I think you guys are getting how this goes. 1.008 grams per mole. But there's times 2. So that's going to be 2.016. You know, if you just multiply by 2, you'll get this. Grams per mole. And we have to add this one and this together, right? This is the one oxygen. This is the two hydrogens, and add them together. So let's do that. Clear. 15.999. Oops. Nope. Clear. 15.999 plus, what was it? 2.016. And that's 18.015. 18.0, what was it? 95? Yeah, 15. 15. And that's how many grams of water you would find in 1 mole of water. And remember, a mole is a certain amount, right? So if I have this many, a mole, if I have that many molecules of water, it would weigh this amount. And what is this many, a mole? That's Avogadro's number, 6.022 times 10 to the 23rd power. Just as a reminder, this is Avogadro's number. And if I have this many molecules of water, it would weigh this many grams. That's all this means. That's what molar mass means, okay? Let's do SO4. So SO4, I think I'm not an expert at chemistry, but I think it's sulfate or something, or sulfite, I'm not sure. Anyway, there's 4 oxygens, 1 sulfur. So let's just do the oxygens first then, because we already know those are 15.999 each, and we're going to times them by 4. There's 4 of them. And what does that equal? 15.999 times 4 is equal to 63.996. 63.996. Okay, that's how many grams per mole of the oxygen part. What about the sulfur? We're going to have to look at the periodic table, and let's find sulfur. Here it is, 32.06 just by itself. That's pretty heavy. 32.06. 32.06. That's the sulfur, you know, S. And so just add these two together, right? We got 4 oxygens, 1 sulfur. Add them up. We already have this number here. Plus 32.06 is 96,056 gram per mole. This is grams. G. Looks like a 9 right there. Grams per mole. So this is how many grams right here you would find of this stuff per mole of it. Okay, that's all that means. And lastly, let's do this last one. Let me put a little line here. See if I can get some extra space. So here is that sulfate. I found it here. But there's 2 of those. So just know if there's parentheses, it's saying that this big fat molecule right here, that there's 2 of those attached to this 1 sodium. So we have sodium, and we can find that one real quick. Just look up sodium. I think it's over here on this side. There we go. 22. You don't have to write all that down. 22.9. We'll just put 989. 22,989. How about that? 22.989. And that's how many grams per mole. You could put 2 or 3 numbers here, and that's all you need. That's more than enough. And then let's figure out SO4. How much does SO4 weigh? Well, we actually did that, so you can do it again if you want, but 1 SO4 weighs 96,056. 96.056. That's how much 1 weighs. But how many? So if we didn't do this one yet, you would have to go ahead and figure out how much that is. You would have to look at a sulfur and 4 oxygens, add them together, and get this number right here. But we're going to times it by 2 because there's a parenthesis, remember? And the 2 here. So there's 2 of those. So 96.056, there it is, times 2 is equal to 192.112. 192.1, I already forgot, that's my memory, 112. And that's how many grams per mole we would have of 2 of those big old sulfates. But plus there's the sodium, so we got to add that 22.989. We're literally just adding all that, the weight of every atom up. You know, that's all we're doing here. We're just calculating all these molar masses of all the atoms and adding them up. That's as simple as that. You just can't get lost. This is the biggest ones you're going to see is when there's these parentheses and you have like a molecule and there's like multiples of those. That's the hardest one you're going to get. So let's go ahead and add this 22.989. So 22.989. And we get 215.101. 215.101 grams per mole. So if I have a mole of this, and those are pretty big, right? There's a lot of molecules and atoms all squished together in a big ball, you know. And if I have a mole of them, it would weigh 215 grams, so, you know, a significant amount of weight. And that's all there is to it, folks. Your assignment is just to go on here and do the worksheet here where you pretty much find all of these. So this one you have one carbon, 3 hydrogens, another carbon, 2 oxygens, and a hydrogen. This one you have 1 sulfur and 2 oxygens. This one you have 3 hydrogens, 1 phosphorus, 4 oxygens. This one you have the NH4, so 4 hydrogens and 1 nitrogen, right? So figure that mass out, but times it by 2 because there's 2 of them. And then your SO4 again, right? Which we've already calculated actually. This one's lead. Number 13 is lead, so find out the molar mass of lead. And then you're going to have to, by itself, figure this one out, NO3. 3 oxygens, 1 nitrogen. What's the mass of it? Figure it out, then times it by 2. See, there's 2 of them. So that's all there is, and here's the biggest one right here. You'll have to figure out the mass of 3 oxygens and 1 sulfur right here, this SO3, and then times it by 3. There's 3 of them, and add that all together. And then add it to this 2 galliums. Okay, and that's going to be your hardest one, probably number 14. And other than that, it's pretty straightforward and simple. So if you have any questions, make sure you email me or ask me any questions that you need.